Good morning, pre-calculus class. So here's another section. So it's the last section of chapter 7. So this one is about solving trigonometric equations with inverses trig ratios. Okay, so we'll take a look at that in just a second. Okay, so here's the one, 7.5. So here are some of the warm-up problems you guys can try. So we're solving equations, linear, quadratic, radical. So again, linear, so that means only one solutions. Quadratic, so the highest power is 2, so we're going to come up with two solutions, either 2 real or 2 imaginary, or 1 real, but it's a duplicated solution. And then number 3, it's a radical, so we're going to end up with one solution for that one. Okay, so now let's look at that, the lecture we have today. So try to do the warm-up problem. Those are the solutions for the equations. So solving trigonometric equations. So now, anytime that you solve for the trigonometric equation, that means we want to find out the original value of the angle. Okay, so let's say like we do have 2 cosine of x plus 2 equals 0. So one thing that we can do, we can set up that z as a dummy variable. So let z equals cosine of x. So once you do that, so this technique is kind of like doing with the substitution. So you want to solve for z first. And once you solve for z, you can unpack, and then you can solve for cosine of x. You can find out the value of x. So once you solve for z like that, it's -1, so it's linear. And then we just said that -1 equals cosine of x. And back to what we talked about earlier, 7.4. So finding the inverse trig ratios, well, the trig angle. So what we got here, it's the inverse of cosine of -1. So inverse cosine of -1, according to the ratio, it's right here, along with that pi, so that means that angle right there, it's pi. So for the solution set, it's pi. And now let's try another one. So 7 cosine of x plus 12 equals 6 cosine of x plus 13. So we do know that the highest power for the trig function is linear, so we just bring everything to one side. So we want to subtract that 7 cosine of x and 6 cosine of x. Or we can set it as the dummy variable with cosine of x equals z. So let's just solve for z first. Linear, so bring everything 7z, 6z together. So we do have z equals 1. Once again, we want to unsubstitute, and then finding the inverse of cosine of 1. So cosine inverse of cosine of 1, according to the unit circle, it's allocated in quadrant, it's right between quadrant 1 and quadrant 4. So the angle right there, it's 0. So 0 radian. And now, what about for sine square of x equals 3? So according to the equation, it's quadratic. So people might be considered using the dummy variable again. So z equals sine of x. So we're using 4z squared equals 3. Divided by 4 both sides, so we do have z squared equals 3, 4. Take the square root both sides, we do have positive negative root 3 over 2. And then this time we need to find out the inverse sign of the ratios of positive and negative root 3 over 2. So back to the unit circle, root 3 over 2, positive, negative. So for sine, we're looking at the y value. So it looks like it's going to be in quadrant 1, 2, 3, and 4. So in quadrant 1 and 2, we do have the angle 60 degree, 120, which is pi over 3, 2 pi over 3. And then looking down in quadrant 3 and 4, negative root 3 over 2, we do have 240 and 300 degree. So it's 4 pi over 3, 5 pi over 3. And finding all those ratios, so we're finding the angle here. So it's pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. And as you can see that they're all considered the multiples of pi over 3. Okay, so now here's some of the example you guys can try. And here are the solutions. Okay. So now let's see what else that we have. So what about getting a little bit more sophisticated? So let's say that it's considered quadratic equation. It's a quadratic trinomial. So one thing that you want to do, again, you can always set up the variable, the substitution. Replace that sine of x by z. And then for this quadratic equation, we're going back to algebra 2, so basically we can factor it. So once you factor, we got 2z plus 1 times the quantity of z plus 1. And then solve for z. We do have negative 1/2, negative 1. And then once we get those z value, guess what we can do? We can just unplug, unsubstitute. And then we take in the ratios of inverse of sine of negative 1/2. So according to that unit circle, negative 1/2, so this one can be found in quadrant 3 and quadrant 4. So according to the radians, so we do have 7 pi over 6 and 11 pi over 6. Now unit circle, that's something you guys need to recognize. So remember way back to chapter 5, we do have a formula quiz based on a unit circle. And then here's another one. Inverse of sine of negative 1, so we found it in between quadrant 3 and 4, so it's 3 pi over 2. So for this one, we do have 3 solutions. So for the solution set, we do have 7 pi over 6, 3 pi over 2, 11 pi over 6. So we just arrange the order from the least to the greatest for the final solution. And now here's another one you guys can try. So once again, replace that cosine of x by using z. Solve for z first, factoring it. So we got z equals 1/2, z equals negative 2. And then unsubstitute. So we want to find out the inverse of cosine of the ratios, 1/2, and the inverse of cosine of the ratio, negative 2. So for inverse of cosine of negative for 1/2, so what we have here, it's in quadrant 1 and quadrant 4. So we got pi over 3 and 5 pi over 3. And now what about inverse of cosine of negative 2? And according to the unit circle, looks like this one, there's no word to be found. Because that for the cosine curve, it's considered a bell curve. The amplitude, it's always bounded from negative 1 to 1. So anything that's lower than negative 1, so there's no solution for this. So that means for this part, it's undefined, no solution. So we only left with the solutions of pi over 3, 5 pi over 3. So now what about secant and tangent? And for those students might be freaking out, secant and tangent, how's that being related? Now one thing that we can do, back to what we talked about for the previous sections in chapter 7, we can always use the trig identity. The Pythagorean identity of secant square of x, if you guys do remember. So secant square of x is considered 1 plus tangent square of x. So anytime they see like a variety trig function involved with the quadratic equations, so you always want to put it into a consistent trigonometric function. So we're using tangent. So replace that secant square of x by using Pythagorean identity. So we do have 1 plus tangent square of x. And then rearrange the order from the greatest power to the least. And then using that, the variable, so we can do the replacement, the z variable. So z squared minus 2z plus 1 equals 0. And then we solve for z first. So we end up with 1 and 1. So you might be saying that's a duplicated solution. It is. So we're going to have the same solution that appears twice for the multiplicity. And then unplug that, unsubstitute z by using tangent of x and finding out the solutions. So inverse of tangent of 1. So inverse of tangent of 1, this one can be found by using opposite over adjacent. So that means it's going to be the same ratio for cosine and sine. So this one can be found in quadrant 1 and quadrant 3. Because positive over positive is going to be positive. Negative over negative is going to be positive. So this one can be found in quadrant 3. So it's 45 degree or pi over 4. And also 5 pi over 4. Okay. So it's pi over 4, 5 pi over 4 for the final solutions. Okay, so here's another one that you can try. So this one, it shows the boundary. So you can find all the possible solution from 0 to 2 pi. So that means, let's say that you go around a unit circle counterclockwise. So you can find all the inverse solution right there. And again, secant of x, we can always using the reciprocals identity. It's 1 over cosine of x. So once you solve for all this, you'll end up with 0, 2 pi over 3, 4 pi over 3. So here's another example. So this one is a double angle. So for double angles of sine of 2 theta, we do have 2 sine theta, cosine theta. So again, it's all about the replacement. And now what about for the rest of the step here? So we can take out the greatest common factor, so which is cosine of x. So we left with 2 sine theta plus root 2 equals 0. And then we set each one of those factor equal to 0, and then solve for theta separately. So take the inverse of ratios of cosine of 0. So we do have pi over 2, 3 pi over 2. And for the other one, so inverse of sine of, looks like that one is going to be negative root 2 over 2. Inverse of sine of negative root 2 over 2, we'll find out that the ratio, the angle would be 5 pi over 4, 7 pi over 4. So totally we'll end up with 4 solutions for the solution set. So here's the last example you guys can try. Again, we can find all the solution from 0 to 2 pi. So cosine of 2x. So we do have 3 different trig identity for cosine of 2x. But this one, you want to put it in terms of sine. So I do recommend you to use that 1 minus 2 sine squared of x. And then once you factor it, unsubstitute, take the inverse, you'll end up with pi over 6, pi over 2, 5 pi over 6. So thank you for watching the video today. So make sure that you guys try to do some of the problem from the homework practice. Alright, so I'll see you guys next time. Take care.